everyone! In this video, we're going to calculate the stress. Actually, stress is an important parameter in order to take into account the fact that different specimens have different cross-sectional areas. Stress needs to be calculated since stress equals to load divided by cross-sectional area. Let's check its definition. So the stress is defined as the tensile force acting on unit area of an object. In order to calculate it, stress is equals to load divided by cross-sectional area. The stress is comparable with the pressure, since the pressure is also equals to the force divided by cross-sectional area. It's actually measured in Pascal, megapascals, and gigapascals. And here are the conversions between the units. Let's return now to the virtual lab. Calculate the stress produced by a load of 50 newtons acting on a specimen with the area of 1 millimeter cubed. What's your answer? Yes, we defined that the stress is equals to load divided by cross-sectional area. The load is 15 newtons divided by the area, which is 1 millimeter squared. So the answer is 50 megapascal. Now let's select the two short steel specimens and apply a load of 15 newtons. Let's plot the graph. How does the strain of the thin specimen compare with that of the thick one? Well, recall that strain is equals to extension divided by original length. The extension for the first sample, which is the thin one, is equals to 13 divided by 40 millimeters, which is equals to 0.325. And the strain for the thick specimen is equals to 6 divided by 40, which is equals to 0.15. So the strain for the thick specimen is half the strain of the thin specimen. Now, how do their stresses compare? Well, since the stress is calculated by the load divided by the cross-sectional area, and since the thick specimen has twice the area of the thin one, then the thick specimen has twice the stress of the thin one. So the thin specimen has twice the strain of the thick specimen because it has twice the stress. Therefore, rather than thinking about a load producing an extension, we can think of a stress producing a strain.